We're back together. All right, so we are looking at question 6. So please, if you haven't subscribed, make sure you're part of the family. All right, so they say to us, given f of x, which is 11 plus 7x, determine f prime x using first principles. Now remember, guys, so when we are going to use first principles, we know that f prime of x, okay, we're going to say is equal to limit as h tends to 0 of f of x plus h minus f of x. This is divided by h, right? So sometimes it might actually help you to work out f of x plus h first, right? So what I mean is we know f of x plus h. It means you're substituting x plus h everywhere we've got x. So we've got 11 plus 7 into x plus h. All right, so something like this. All right, but I'm going to do it right here onto the equation. So please do not drop this guy, limit as h tends to 0 until you substitute by that h is equal to 0. Right, so f of x plus h, that's 11 plus 7 into x plus h, minus f of x. Now remember f of x, put it in brackets, that's 11 plus 7x. And this is divided by h, right? And this is limit as h tends to 0. That's going to be 11 plus 7x plus 7h minus 11 minus 7x. And this is divided by h. Okay, 11 and the minus 11 cancel. 7x minus 7x cancel. And what are we left with? We've got 7h divided by h. Limit. H tends to 0 at 7h divided by h, and well, guess what? So f prime x will simply be equal to 7. And that is how the cookie crumbles, right? So that's how we are going to get the derivative using first principles. All right, let's go on to the next question. They say to us, determine dy dx if y is equal to, if y is equals to x raised to the exponent of 8. So we know we are going to use our law of differentiation, dy dx, okay, dx rather, is simply going to be, we are going to jump down and minus 1. So that's going to be 8x to the exponent of 7. All right, so we won't waste time on that one. Right, and then in 6.2.2, they said find, in this case, f prime. So that's f prime is equal to. So firstly, before we find f prime, let's start by writing this first as an exponent. So that would be x to the power 4, but remember that this root becomes the denominator of the fraction. So x to the power of 4 over 3. So f prime of x will be 4 over 3 x to the power 4 over 3 minus 1. So what do we eventually have? That's 4 over 3 x. Okay, so that will be 4 over 3 minus 1 will give us, that will be 1 over 3, right? That's 1 over 3. Okay, right. If you wanted to express it again as a, as a surd, that would be 4 over 3 to the cube root of x. Okay, but that's not necessary. All right, so we can leave it in that format. So that is f prime of x. Okay, right, and then they say we must differentiate that expression. Okay, so the first thing, before you differentiate, we need to simplify that so that we remove whatever it is that's on the denominator. So that's x squared minus 16 divided by 4 minus x. So please do not remove the dx, the differentiation part. Okay, find the derivative with respect to x. Right, so this is the difference of two squares. So that gives us x minus 4, x plus 4 when we factorize it. But let's write this 4 minus x as negative x minus 4. Okay, right, that's going to help us because in this case what we're simply going to do is cancel that with that, and if we divide by negative 1, so we're finding the derivative with respect to x of minus x minus 4, right? Remember, when we divide it by negative 1, it changes the sign of all that expression. So what do we eventually get? Well, that is simply going to be equal to negative 1. Okay, right. So that is how the cookie crumbles. That's the only variable in that case with respect to x. Okay, that has a coefficient of negative 1, and that's about it. All right, ladies and gents, we'll leave it there. So we will look at 6.3 in our next video. All right, and we will take it from there. For now, I'll see you guys next time. Sharp, sharp.